Why fuels are used to run the vehicles? Why plants need light energy to produce sugar and oxygen? By the end of this video, you're going to find the answers. Scientists have discovered many mega-galaxies, but there were also very tiny galaxies that could only be seen with a microscope. One of these was the galaxy of molecules, inhabited by nonmetal molecules who lived happily and peacefully. One day, they had a visitor who resembled a UFO, but the molecules called him the heater, because he emitted heat that could break the bonds of molecules in the gaseous state. Heat is another form of energy. The heater first visited the lightest molecule city, Hydrogen City. He released energy directly at the hydrogen molecules, breaking the bonds between them. Satisfied with his work, he moved on to Carbon City. The heater used the same amount of energy on the carbon molecules, but because carbon molecules had double bonds, this energy was insufficient to break them. The heater had a top-secret document stating that 1 mole of carbon double bonds required 612 kJ of energy to break. He increased the heat to 612 kJ and directed it at the carbon molecules, successfully breaking the bonds. However, he overlooked one crucial detail. When atoms form molecules, they release the same amount of energy. As the carbon atoms rebonded, they released 612 kJ of heat into the surroundings. Unhappy with this outcome, the UFO left the galaxy of molecules entirely. Here is an example. Show the sum of energies on each side of the reaction. Let's animate this reaction. To produce hydrogen bromide, the bonds of hydrogen and bromine molecules must first be broken. As you can see, the molecules are broken down. Now, it is time to form hydrogen-bromide bonds. Hydrogen and bromine particles form bonds by releasing heat. This heat is equal to the bond energy of the hydrogen-bromide molecule. Our final step is to sum up the bond energies on each side. On the reactant side it is 629 kJ, on the product side it is 736 kJ. The last example. Does this reaction absorbs heat or releases heat? If the energy absorbed to break the bonds is less than the energy released in making bonds, the reaction gives out energy. If the energy absorbed to break the bonds is greater than the energy released in making bonds, the reaction takes in energy. The released energy on the product side is greater than the absorbed energy on reactant side. For that reason, hydrogen bromide in the bottle gives out heat. Propane is used as a fuel for vehicles. On the reactant side, breaking the bonds requires about 6,490 kJ. On the product side, forming the bonds releases about 8,498 kJ of energy. Since the energy released in forming the products is greater than the energy required to break the reactants' bonds, the reaction releases energy which is used to run the vehicles. Plants take in water and carbon dioxide to produce sugar and oxygen gas. On the reactant side, breaking the bonds requires about 15,144 kJ. On the product side, forming the bonds releases about 14,485 kJ. Since breaking the reactant bonds requires more energy than is released when forming the product bonds, the reaction has a net energy deficit. This means it needs additional energy to proceed, which comes from sunlight. In conclusion, heat is another form of energy. That is why joule is a unit of heat. Breaking bonds requires heat. Making bonds releases heat. Molecules must be in a gaseous state. The amount of heat to break or form bonds in a gaseous molecule is called bond energy. This is the table of some bond energies.